Hey everybody. So, like I said, I'm going to be doing a video on this new topic that we're learning, algebraic expressions. If you remember, algebraic expressions pretty much just means anything having to do with math that has a variable and no equal sign. So, right here we see a bunch of math with no equal sign and variables. These are algebraic expressions. Since I've already gone over these in class, I'll go over them pretty quickly, just as a review, and then I'll move on to some other practice problems. So the first thing I'm going to go over is this 3x plus 1 half plus 7x minus 4.5. All right. So because there's no equal sign, we're going to be doing PEMDAS. Because remember, SADMAP is for when you're going over signs and moving things from one side of the sign to the other side of the sign. So since there's no equal sign, no inequality sign, we don't have to worry about SADMAP. We're going to be doing PEMDAS. So PEMDAS is the order of operations that you will use when there's no equal sign, there's no inequality signs, there's none of that. So PEMDAS, first is parenthesis. So this is one of the few times where you're going to be consistently using parenthesis to do whatever you need to do. So we're adding every single thing inside the parenthesis. So we're going to be adding 7x. We're going to be adding this minus 4.5, which you can just write it as minus 4.5, but we'll go over that. 3x, no, what? There we go. 3x plus 1 half. Cool. We didn't really have to do anything there. So we just added this entire parenthesis, whatever's inside. So now I'm gonna break these up into terms. into terms. If you have a question on how to do this, we should practice it more, because this breaking things up into terms should be pretty standard by now. Sorry, I just had to take a drink there. Something was caught in my throat. Okay. So we're now going to combine like terms. Okay. Combining like terms, if you remember, like terms are terms with same variable and same exponent. It doesn't matter what else is in the term, as long as they have the same variable and same exponent. So that will mean that these two are the same and these two are the same. So these are our like terms, because these both, ooh, that's red. These both have x's, and these both don't have any variables at all. So that's what makes them a like term. So if I were to work these out, only like terms can interact with each other. If they are not like terms, they cannot do anything. Adding, subtracting, multiplying. They can multiply, divide, but we'll go over that. They cannot add or subtract. So we have 3x plus 7x. And here we got positive plus 1 half. And then we got plus negative 4.5. Okay. If you're having issues with plus negatives and minus positives, things like that, come to office hours. We'll go over it. We'll practice. Because you should be decently comfortable with stuff like this by now. 3x plus 7x, 10x. 1 half plus negative 4.5, that's just going to be negative 4. So the final answer for this will be 10x minus 4. Now, there's nothing else we can do. These are not like terms, so we can't really do anything else. Okay. Now let's do the next one. Negative 0.25 x minus 3 minus 1.5 x plus 1.4. All right. Again, remember, we're using parenthesis first. We are minusing everything in here. So we're going to be minusing the 1.5x. We're going to be minusing the plus or positive 1.4. We're minusing everything. So here, we just bring it down. There's nothing in front of it. Oh, that's not what that was written there. There we go. Okay. I'm gonna break up my terms. Now you don't need to break up your terms. This is training wheels. This is just for you to see what I'm doing. If you don't need to do terms, if you can just see how the terms break up, that's perfectly fine. This is really good to do if you can't see it right away. Nothing wrong with it. It doesn't even really add that much time. So these both have x's. These both don't have any variables at all. So these are my like terms. These are my like terms. Okay. So what do I got? I got negative 0.25 minus 1 x minus 1.5x, negative 3 minus 1.4. Okay, so I put these together, I end up with negative 1.75x minus 4.4. And there we go. So that is, again, nothing else I can do. These are not like terms. I can't combine them. So this is as far as I go. So now for a couple more practice problems. So this one is now using something called the distributive property. If you remember, the distributive property means that I can take any number on the outside of a parenthesis and multiply inward. So let's say we got 7, 9k plus 6m. So multiply inward. So 7 times, so distributive property, whenever you see a number on the outside, a parenthesis on the inside, multiply into it. We kind of talked about this before break, very briefly. If you don't remember, don't worry about it. I'm going to teach it to you again, because this is something that you need to know. So multiply to everything on the inside. So we're going to do 7 times 9, which is 63k. 7 times 6, which is positive, so this is 42m. You're literally just multiplying the front parts and then plopping the variable down at the end. Nothing crazy here. So we got 0.2, now I'm on number 6. This is done. So not simple, but so fast, so easy. There's only one step. Literally just multiply to everything inside. So 0.2 3b minus 15c. Cool. Again, I'm just multiplying inwards. Just multiplying in like that. So 0.2 times 3, it's 0.6b. 0.2 times 15, was that like minus 3c? Yeah. Cool. Then up for another one. This one is a little bit tricky now. If you're not good with fractions, this one might take a little bit longer, but the steps are not any different. You got 6e plus 9f. And if you need me to go over how to do fractions, office hours. I'll definitely go over and teach you fractions if you need it, because I'm not going to spend too much class time on it, but I will help you with anything that you need in office hours. Again, I'm just multiplying it to every single term. And if you need me to separate the terms, how I've been doing this, so like that's a term, and that's a term, that's a term. So I'm multiplying it to every single term. Every time there's a term, I'm multiplying it. That's where I'm getting these. So, where was that, green? So 2/3 times 6, what is that, 12, or that's 4e. 2 times is 18 over, that's 6f. Again, I'm just doing it in my head, but you should be able to do fraction multiplication. So this is 2/3 times 6. This is 2/3 times 9. 2/3 times 21, which is, what is that, 14? Yeah, 14g. There you go. I'm literally just multiplying the fronts, plopping the variable at the end. That's distributive property, super straightforward. Not necessarily easy, but super straightforward. Okay, so factoring. This part is factoring is essentially doing distributive property backwards. So before we were taking a number on the outside of the parenthesis and we were multiplying inwards. We're now going to be taking an expression and pulling out that number. So for example, here I have 2x plus 2. Now, what I'm going to do is I'm going to break up my terms. Again, if you don't need these boxes, you don't need to make them. These are not mandatory. I'm going to take my terms. I'm going to say, okay, what can I divide both of my terms by? Well, it looks like I can divide 2 to both of them. So what I'm going to do is I'm actually going to pull that 2 out. Ooh, that's a box. There we go. I'm going to pull the 2 out and divide. So what's 2 divided by 2 divided by 2? So that 2 gets pulled out. 2 divided by 2 is 1, so I can put 1x plus 2 divided by 2 is 1. So 1x plus 1. Pretty much I'm just doing the opposite of what I was doing before. Before I was multiplying inwards. I was multiplying the outside going in. Now I'm dividing the inside going out. And what I need, this is called factoring. What I'm doing is I'm just saying, okay, I can divide all of my terms by the same number. Let me pull it out. This is the backwards motion of distributive property. So let's try it again. So I got, no, I just did 2. This one was 3x plus 9. Okay. So again, I'm going to break up my terms. Okay. And then, okay, so I have 3x and I have 9. So I don't really care about the variable right now. I can divide both of these by 3. So I'm going to go do that. I'm going to pull the 3 out. So the 3 goes outside. 3 divided by 3 is 1x plus 9 divided by 3 is 3. There you go. If it seems easy, it's because we're doing, it is a little bit easy. The hard part is figuring out what you need to divide, but once you figure that out, it's pretty straightforward. Again, 5x plus 15. So I'm going to break up my terms like that, like this. Cool. Okay. I can divide both of them by 5. Right? 5 divided by 5, that works. 15 divided by 5, that also works. So 5 divided by 5 is 1. Oh wait, I should pull out the 5 first. 1x plus 15 divided by 5 is 3. There you go. That's the factored form of this. So when I say to factor, or what's the factored form, I'm talking about this. I'm talking about the 2 with the parenthesis. I'm talking about a number with a parenthesis. You're dividing every single term by the same thing and pulling it out. So again, we got 4x plus 16. So I'm going to break them up into terms. Divide. This one's a 4. That's 16. I can divide both of these by 4. So I pull that 4 out. Parenthesis, 4 divided by 4 is 1x. 16 divided by 4 is 4. And there we go. And that's pretty much the last topic. So the 3 topics that we went over today is combining like terms. So again, just follow your PEMDAS. Remember, when you're subtracting a parenthesis, you're subtracting everything in that parenthesis. When you're adding everything in the parenthesis. Like terms, they'll always have the same variable, same exponent. If there's no variable, then they're also like terms. Distributive property, pretty much we just took the number on the outside, multiplied it to everything on the inside. And factoring, it's the opposite. We took all the terms on the inside, saw what we can divide by, and pulled it out. So that should be pretty much enough basic knowledge to get you through the assignment. Again, remember, you can always come to office hours. We can talk about it in class. Totally, this is the first time you're seeing it, so I'm not expecting you to do 100% on it right away. If you do, awesome. If not, don't worry. We're going to work on it. So that's it for today. I will see you on Thursday, and good luck.